Hi, so I have this integral on the board, square root of 4x squared plus 4x minus 35 dx. And it's my first thought is I want this to be a perfect square, but I can pretty much see that it's not. So in factoring, even if, I don't know if you could factor that, but even if you factor that, it's not going to be nice at that point. So what I want to try is completing the square on this polynomial here. So let's look at that. What I want to do, if I square 2x plus 1, 2x plus 1 squared is going to be 4x squared plus 4x plus 1. Now, what if I take this and I subtract 1 and then subtract 35? This is 0, so then this is equivalent to that expression right there. So I've just completed the square and gotten into a form that I think we can use, because then if we combine minus 1 and minus 35, we get a minus 36. So what I can do is to rewrite this whole thing. We can rewrite this as the square root of 2x plus 1 squared minus 36 dx. And if you need to multiply that out, and you can just verify that that comes to the same thing as our original integral by completing the square. So then this is looking nicer, but this is a perfect square right here. And what I could do to simplify this more is use a u substitution. So let's do that. I'm going to substitute u equals 2x plus 1. And then if we just take the derivative on both sides, we get du is equal to 2 dx. And that's going to be useful. What I'm going to do is let me just pencil in a 2 right here. And then so that I don't change the integral, I'll put a half here. So I'm really just multiplying by 1. But then we're going to have a u here. I'm sorry, this is going to be du, and this is going to be u. So again, let's rewrite it. We have a half square root of u squared minus 36 du. Okay, so that's going to be a little nicer, because then, now that we have this integral, we can do a trig substitution. And you should look out for that whenever you have, especially when you're, yeah, when you have an integral with, usually with something squared, or particularly in a square root, there's usually a trig sub for it. And in this case, the best one to use is going to be secant. So what we'll do then, we'll make the substitution u equals 6 secant of t. And you'll see, if you don't see that yet, you'll see it soon, because when you square that, the 6 is a 36. And then du is going to be just a derivative of 6. The derivative of secant is secant times tangent. Now we'll continue with the substitution. So we'll have a half on the outside. And then inside the square root, we want to substitute for u. 6 secant of t is going to be 36 secant t minus 36. And then our du is just going to be this guy, which is 6 secant t tan t. Oh, there's a dt right there. dt. Okay. Then we can pull this here is gonna, this piece here is gonna break down as 36. Oh, and sorry, this is a square right here. So this, if we factor out a 36, we can write this like this. But then when this breaks up, square root of 36 is just 6. And we have a 6 here. So what we're gonna do is we're gonna pull this to the outside, pull this out. All right. We'll rewrite it. So we're going to have, this will be a 36 over 2, right? 6 times 6 is 36 over the 2 that we already have. And then we're going to have this secant squared of t minus 1 times secant of t tan t dt. Use this trig identity, tan squared of t plus 1 equals secant squared of t. This actually comes from just the more familiar cosine plus sine squared equals 1, just dividing through by cosine. And then from here, we can rearrange this by subtracting a 1 on both sides. And we have secant squared minus 1 equals tan squared. So we'll use this in here. So if this thing is tan squared t, and we're inside a square root, then this whole thing is just going to be tan of t. So then multiplying with this, let me rewrite this, and we'll simplify this to be 18. So we have 18 integral of tan squared of t times secant of t dt. But again, I'm going to go right back to this same formula right here and go back to have that as secant squared minus 1. So if this is going to be secant squared minus 1. Sorry, that's messy. That's secant squared minus 1. Then what we'll do is we'll distribute the secant, and here we'll have 18 times the integral of secant cubed of t minus secant of t dt. For this integral here, I won't go through all the steps of finding this, but these two are common integrals, and I have an integral cheat sheet that is in the description of the quiz. I can provide that as well, that has some of these common integrals. But so these both are well-known integrals. Let me just write that right here. So the integral of secant of t is just ln secant of t plus tan of t, absolute value. And then for secant cubed, let me get a little more space. This one is just going to be half secant of t tan of t plus okay, and then notice that the last two terms are basically the same, just a different coefficient. So let's just rewrite this real quick again. And I'm going to distribute the 18 to the inside, and we're going to have 9 secant of t tan of t minus, because we got a minus sign here, minus a half ln secant of t plus tan of t plus c. And now we're getting close, but because we've done all of our integration, the only problem is now our variable is t, and we want to get back to u and then back to x. So we got a couple of steps to do. But what we need to do is remember what we had for secant of t. So let's go back. What we have is u equals 6 secant of t, which we can rewrite as secant of t equals u over 6. And what we just need to do is draw our right triangle and just figure out what all the sides correspond to. So we can draw this. So remember, if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So we're going to have u over 6. Then we can figure that the third side is going to be u squared minus 36. Now, if you need, you can just use the Pythagorean theorem, but you can verify this. If we square this, add it together, we're going to have u squared. A squared plus b squared equals c squared. Okay, so then from that, we can figure out if whatever trig values are in this problem, we can figure it out because we know, all we need is, we know secant already, it's this, but for tangent, okay, so we know, we have our secant value, but we need our tangent value. So tangent is going to be opposite over adjacent. So we can say that tan of t is going to be square root of u squared minus 36 over 6. Now that we have that, we can just go and plug it back into our result here. And what we're going to have 9 u over 6 square root of u squared minus 36 over 6. Absolute value, I don't know why I changed colors, but let's just go with it. plus square root of u squared minus 36 over 6. Now plus c. What I'm going to do is, the 6 is just going to be a constant value. I'm going to just factor that out. Because if you factor the 1/6 out of this, you could, by the rules of logarithms, you could like pull out would be like minus ln of 6. And that would just be absorbed in the constant. So I can just cancel that. And then for the next step, now we're really close. Okay, so this is going to be 36. If we cancel here, we end up with 1/4. 9 over 36 is a fourth. What else can I do? Oh, so I think really now the only problem is we have it in terms of u, and we just need to get this into x. So let's solve that. So we have our value of u right here, u equals 2x plus 1. So we'll substitute that back in. We're going to have 1/4 times 2x plus 1 square root of, now when I plug 2x plus 1 into here, I'm going to get back to my original integral. Okay, next we have minus a half ln of u again, which is 2x plus 1 plus this original integral, which was 4x squared plus 4x minus 35. Absolute value plus c. And that's it. You can distribute there, but it doesn't really matter. So this is the whole solution. Kind of a little bit of work. So we completed the square. We did a u substitution. We did a trig substitution. So quite a bit was included in this. This one comes from my integrals with roots quiz, which has a mix of trig substitution and algebra and some other stuff that I'm probably forgetting. But I'll provide a link to those, and I'll provide a link to that in the description of this video. And that's it for now. Thanks.